This problem says, in the drawing, the weight of the block on the table is 422 newtons and that of the hanging block is 185 newtons. Ignoring all frictional effects and assuming the pulley to be massless, find A, the acceleration of the two blocks, and B, the tension in the cord. I'm going to do this problem in two ways. The first one of those I'm going to call the quick way, and later I'm going to do the proper and more consistent way of calculating this. This is a re-recording of this problem because I ran into a problem with this one here, and it's mainly connected to the pulley redirecting the forces, and so that's why I'm re-recording it, and you may or may not see actually the original one. In any case, I'll talk about that a little bit later. Let's do the quick way first. So here basically what we're gonna have pulling the whole thing along is that the weight of the second block at 185 newtons is pulling this one down. So the sum of the forces equals mass times acceleration, and that comes out to W2 equals, well, the mass of the system, which is the two actually connected. The masses here, they're connected by the rope, so they're the two that are accelerated, so it's m1 plus m2 times the acceleration. And the mass of the first block, of course, is easily calculated as basically I'm dividing 422 newtons by 9.8, and I come up with 43.1 kilograms, and here I come up with 185 newtons divided by 9.8, so I come up with 19.0 kilograms, and then that should read m2 and that should read m1, and then the acceleration we're going to get as the weight of the second block divided by the two masses added together. And if you look at that, you actually do come up with a negative acceleration because the weight here is negative and that block is being accelerated down. Okay, actually this quick way leaves open a few questions, one of which is, well, what actually happened to the tensions? Well, because I looked at the two blocks as one here, as one system, with of course the second block here being the sole force that is pulling it along, I didn't need the tensions, and by the way, these are the tensions here, T1 and T2, because they are internal to the system, so they're not acting on the system from the outside, doing anything on it. I also didn't talk about the weight here, because that weight, so weight 1 of negative 422 newtons is countered by the normal force of positive 422 newtons, but they are perpendicular to direction of the motion anyway, and they cancel each other, so that's why they don't enter into the equation, and really the only force that I needed was the weight pulling this one down here. Sorry, this was supposed to be vertical. Okay, what now is the proper way and a consistent way of doing this kind of problem? Well,